Good afternoon, everyone. Hope everyone is doing well. So welcome back to machine learning, day 2. So we're going to dive a bit deeper into supervised machine learning by exploring classification tasks. So in this lesson, I'm going to introduce you to the concept of classification, highlighting how it differs from regression, what we looked at yesterday. So when we look at what classification is and its role in supervised learning, the difference between binary and multi-class classification, how decision trees work as intuitive and interpretable classifiers. We'll build a decision tree classifier in Python, and then encoding categorical data for machine learning, splitting data for training and testing, evaluating model performance with accuracy and confusion metrics, visualizing the decision tree to understand model decisions, basics of avoiding model overfitting with depth limitation. So that's for day 2. So let's begin by defining what classification is, and I could say it's basically predicting discrete categories or classes instead of continuous values. A few examples, let's say email spam detection, spam or not spam, medical diagnosis. So there are disease categories in medical diagnosis, and then let's look now at binary classification versus multi-class classification, like an overview. So we have what we call decision trees. Now, how decision trees work is we're splitting data based on feature values to reach classification decision. One of the advantages is it's easy to interpret, handles both numerical and categorical data. One limitation is it's prone to overfitting if it's unpruned. So in our example for the code, the demo that I'm going to show, we're going to build a decision tree, predict whether fruit is an apple, orange, banana, based on size and color features. In summary, the code I'm going to show is going to demonstrate how to build and evaluate a decision tree classifier for a simple fruit classification task. We'll start by preparing a small data set with features describing fruit size and color, and then convert the color information into a numeric format that the model can understand. Then we'll split the data into training and testing parts, like what we looked at yesterday, to allow the model to learn patterns and then be evaluated on unseen examples. The decision tree model is trained to classify fruits into categories like apple, orange, or banana based on the features. And then after training, the code predicts the fruit labels on the test set, then calculates the accuracy of those predictions. and then shows a confusion matrix to provide insight into specific classification results. Then finally, it will visualize the decision tree structure to help understand how the model makes its decisions here. So that's what that's what we expect Python code to do. So let's get straight into it. Of course, we start by importing our libraries. So we'll have road. Yes, the world. Bow down and see you on blood. script. So yeah, this is the script. Mind these warnings. Just like yesterday, they didn't affect any of the output we expected. So yeah, so let's break it down. Of course, the inputs, pandas helps organize and manipulate data in tabular form. So I'm breaking down what each of these inputs does. So the pandas input helps to organize and manipulate data in tabular form. So that's why we have the data frame here on line 15. And then the train test split basically randomly splits data into training and testing sets. The decision tree classifier is the decision tree model for classification. Yeah, here. The plot tree lets us visualize the structure of the train decision tree. And then accuracy score here from line 4 and the confusion matrix provide evaluation metrics for model performance. And then the last input, matplot library, allows us to create plots and graphs. Yes, then from line 7 to 12, there we have created a Python dictionary containing our dataset with 3 columns. That is size, color, and label. The size is a numerical feature representing the size of each fruit. Excuse me. The color is a categorical feature describing fruit color as words. And then the label, that's the target variable we want to predict the fruit type. So whether it's apple, orange, blah 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 blah. And then yeah, from line 14 to 15. So line 14 basically is a comment I put in to just help you understand what's going on. So that line 15, we convert the dictionary into a data frame. So we're converting this into a data frame so that it can be a table basically. So it converts it into the dictionary into a data frame which resembles a spreadsheet or a database table. And each row represents one fruit with its features and a label. The feature being the color and then the label being, what type of fruit it is. And then from line 17 to 18, the machine learning models work best with numbers. So the categorical color feature is converted, this one here, the color, the categorical feature, which is a color, the categorical color feature here, is converted into numeric columns using what we call one-hot encoding. And then so basically it creates new columns like color red, color orange, and color yellow. Each column has 1 if the fruit is that color, otherwise 0 if it's not that color. So yeah, you should know that it is going to create columns color underscore red, color underscore orange, and color underscore yellow. But each column has 1 if the fruit is that color. If it's not that color, then it's 0. and then from line 20 to 22, so X is holding all the feature columns that the model will use as input to learn from, and then Y holds the labels or actual fruit types the model tries to predict. So that's what those two lines do here. And then the part where we start to split the data into training and testing sets. So we're splitting, that's why I took some time to write the code, the comment here. So basically, if you read the comments from here, I was trying to just explain what that line 26 is doing. So it's splitting the data set into training data, 75% to teach the model, and then 25% of that data is for testing, basically to evaluate model performance on unseen data. And then that part here, random state is equal to 42, ensures the split is the same every run for reliable results. So every time we run it, it should be the same split. Okay, and then 28 to 29, basically line 29, we create a decision tree classifier object. So line 29 initializes the decision tree model and then limits the maximum depth to 3 to prevent the model from memorizing training data too closely, which is called, or what is defined as, overfitting in machine learning. And then line 34 to 35, line 35, it uses the trained model, the model trained above, to predict the fruit types on the test data which the model hasn't seen before. And then line 38, we are basically calculating the accuracy. So that line compares predicted labels the predicted labels, Y predict, against the true labels, which is this one, Y test, and then computes the percentage of correctly predicted fruits. And then line 40 and 41, we generate a confusion matrix. So line 41 basically creates a confusion matrix to show the detailed counts of correct and incorrect predictions for each class, which will help to understand where the model made mistakes. So in case the model makes mistakes, it will help us understand where exactly. And then of course this whole bit from 43 to 46, we print the accuracy as a decimal with 2 digits. That's what this is after the decimal point. And then we print the confusion matrix as a labeled table for easier interpretation. That's why we print the confusion matrix as a labeled table. Print PD data frame confusion matrix for easier interpretation. And then of course from there we visualize the decision tree. So 49 sets, line 49 here, sets the size of the plot, and then draws the decision tree showing how data is split at each node based on feature values with colored nodes representing the different classes. So that's what line 50 is doing. And then we add a title and display the visualization, helping to understand the decisions the model makes. Yeah, so that's it. And then yeah, so if you run this script, we're expecting some terminal results and then a visualization of the decision tree. So let me run it. Okay, so here are results. Let me make sure you're seeing. I hope you can see the visualization as well. Okay, yeah. So let me first minimize this so we can look at the terminal results first. Okay, yeah. My streaming up is sort of ahead of the stream. That's why I wanted to make sure the visualization was minimized. So yeah. So our accuracy right now is at 1, and here's the confusion matrix. So we have apple, banana, orange. Okay, and then the visualization. Interesting. So yeah, based on the terminal results, the model achieved an accuracy of 1, which means it correctly classified all the test samples it was given. So that's an accuracy of 100%. That's an ideal performance score indicating perfect predictions on the test set. Then if now we're looking at the confusion matrix, the model predicted the only test example labeled as apple correctly, so that's one true positive for apple. So there are no test examples classified as banana or orange in the test set. Oh sorry, so this is still maximized. Yeah. Sorry, there are no test examples classified for banana. There's only one for apple and one for orange, which is okay. So yeah, that's it. That's decision tree classification in machine learning. Thank you for tuning in. Don't forget to like, subscribe to the channel, share the video. We'll be back tomorrow, same time, to look at what we'll cover in day 3. Have a blessed evening.